Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items: our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our channel. And if you've not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to access and interact in the chat. You can set that up now, and if you're unable to use the chat but have questions, feel free to reach out to us through social media or on Meetup. Which brings us to today's session. I'm going to bring in our two speakers for today, Landon and Ricardo. Hello, how are you?
Hi, everyone. Happy to be here.
Fantastic. Thank you so much for joining us today. And yeah, please take it away.
Sure. Thank you so much, Alexia. So let's kick it off. My name is Ricardo Villarreal. As Alexia already mentioned, we're going to be presenting this together with Landon, my partner in crime in this product. Thank you. So this is a session about programmable connectivity, about how applications can access programmable connectivity. We're going to tell you about a product that we are building. We are currently in private preview. So we are excited about sharing this with you. Can you, next? So first, we want to tell you about the problem that we are fixing, the opportunity that we see. Basically, what we see is that applications, they are different today. They are evolving. They are evolving into a paradigm that we called modern connected apps. Basically, these applications, they are running on many different places. They are running on compute that is on cloud regions. They are running on private Mech, public Mech. They are even running nowadays in space compute, or they could be even running on the edge on an IoT device. So the reality is that the workloads of these applications are spread across all of these compute locations. In some cases, it's not just the application that is in a different place. It is that the application has different components running on different places. They are highly distributed. So that's on the left-hand side of this slide. On the right-hand side is the networks that these applications are using. These they are using many different networks, right? They could be using a public network, a private network, wired. They are now using satellite networks, many of these applications. And something important to highlight is that these networks are also evolving. Now they are programmable. So that is what part of a gap and an opportunity that we see. Next. So basically, the opportunity that we see, or the gap, if you will, is making a better connection between these applications running on all of these compute targets and making use of all of these diverse networks that are programmable. So we have a vision for a product, the product that we are building, which is the vision for the network programmability, which is basically, this is a product for developers, right? And what we want to do is provide developers with the best tools to write and deploy these network-aware apps. So these are going to be apps that are network-aware, that can talk to the network. And they're going to be using diverse networks, as I mentioned before. But something very important always in Azure is that we provide a consistent experience. You don't have to be, you don't have to have different experiences depending on the different compute targets or depending on the different networks that you are accessing. So the three most important things that we are providing for this product is, one is the network intelligence. We want to make sure that these applications can access the network intelligence of these networks. This is going to be achieved via network APIs. We're going to talk a little bit more about them in a bit. The second thing is that we want to provide unified connectivity. That means that it doesn't matter what network you are talking to as a developer. Everything is from within the same interface, one interface. And the last one is complexity abstraction. you don't have to learn how to program into each of these network, right? The idea is that you also use just one interface, in this case, that you do it with an Azure experience. So the same tools, the same portal that you use today to develop your applications is the same tools that you would be using to communicate with these networks, with the programmability of these networks. So with that, let me show you actually the product that we are building. Next. So the product is called Azure Programmable Connectivity. As I mentioned before, we already released a private preview version of this that was done in the Mobile World Congress back in early March of this year. But this is basically what we are doing. It's the box in the middle, right? So let me walk you through this slide. At the very top, you have these applications that I was talking about. We are calling them modern connected apps. The examples of applications that you see here are actual use cases that we have encountered in the conversations we are having with developers. These are applications that want to talk to a network, that can provide a better experience to their users by talking to the network, by programming the network directly, right? At the very bottom are the operators. In this case, in this first phase, our product is unifying different operators that are exposing the programmability of their networks. So the 6 operators that you see here are already integrated into our platform. They are the first one. We are having way more conversations with other operators to keep integrating them into the interface. But the 6 that you see right here, they are already integrated, and whatever they are exposing to the developers, it is exposed through one interface. So again, what our product does, this is similar to what I mentioned before, but I just want to highlight it again. Our product does 2 things. Is the unification that we mentioned before, is going to be one interface, and the second thing is the abstraction, right? So this programmability of the network is presented in a friendly fashion to the developers. By the way, I want to go a lot into detail here because Landon is going to show you how it works. He's going to give you a demo of the product. So next, Landon. I just wanted to show this to make more tangible what network capabilities we are talking about. What I have mentioned before is, okay, the application is going to be able to talk to the network, is going to be able to program the network. What exactly am I talking about when I say you can talk to the network? What kind of things you can do? This is not a comprehensive list of network capabilities, but these are some of the ones that we have seen that most developers wanna use, and the ones that the operators are exposing. I'm just gonna give you a quick example of each one. Is discovery, optimal endpoint. Using a network API, you can understand all the different places that you can connect to with the different profiles of those places. The profile, most of the cases, means what is the latency for you to connect to that location, right? So you can make decisions as a developer. Okay, I want to run my application in a place. I want to run my application on a different place. Or you can have the devices also making decisions as to where they can connect to the applications in case the application is running in different places, right? By making a discovery API call. Second one is a guaranteed quality of service. Sometimes these applications, they are running in public networks that are crowded. And when they are crowded, latency worsens, and also the jitter worsens, right? So you want to improve it. You can make an API call, and you can improve. Your traffic would be prioritized over other devices connected in that same network. And that way you can continue to operate as if the network did not have congestion. Another one is device location, which is an API call that you can make to the network, and you can obtain the location of the devices that are connected to your application. And this is provided not by GPS, this is provided by network technologies. Sometimes it is ultra accurate, sometimes it's within 1 or 2 centimeters. So it is also very, very useful for many of the developers. And then just 2 last examples. You can move based on all of the information that you get from the network, based on many APIs that you can, many API calls that you can make to understand the status of your devices, the status of the network. You can make decisions on whether, you know what, I'm going to move my workload from this place to this other place, Or the last one is you can make decisions on I want to use more the cloud, I want to use more the edge, I want to actually run things locally today because the network is not working very well. So based on all of this monitoring. So these are the type of network technologies, network capabilities that operators are exposing and that we would be exposing through one interface. Next. So the last thing I want to show you before Landon goes into more details about the product is an example, an actual example to make it more tangible. We are working with Halo. Halo is a very, very interesting company. And we are working also with T-Mobile in this particular use case. What Halo does is they rent cars by the hour, very similar to other companies, where I only need a car for 2 or 3 hours, or maybe even for the day, right? But the most important thing is that the car is driven to you from an app. You use an app and you say, I'm here, can you drop the car to me? But the car is driven remotely. There is a person, you can see that on the picture on the top. There is a person sitting on a desk driving the car, and the car is driven to you. So it's not autonomous driving, but someone actually driving it to you. So you can imagine the network is very, very important for this. Right now, they've been struggling sometimes with places where there's a lot of congestion, places where there are many people, many devices. So what they do is they are using a quality on-demand network API. This is the API one of the APIs that I mentioned before that you can use to prioritize the traffic of the device. In this case, it is the connectivity to the car. It is prioritized, and then the latency is improved, the jitter is improved, they have a high throughput, even in crowded locations, and they can continue, and they don't have to avoid a crowded place for that. They can continue to operate in these places, and they don't need it all the time, right? That's one of the beauties of a network API. You make an API call, you enable this quality on demand. As soon as you leave that crowded place, you can turn off that API. Okay, with that, I guess we are ready to go into more details about the product. Landon, thank you.
Thanks, Ricardo. So I'm going to give you a little bit more detail on what Azure Programmable Connectivity does, what it looks like, and I'm going to show you a quick demo that hopefully makes it clear why we think it's valuable. So first of all, I want to talk about the key features for Azure Programmable Connectivity. And so the first feature is credential management. So APC will manage all of the credentials that a developer needs to access the operator's APIs. So in some cases, that means that we will get the credentials directly from the operator. In other cases, we will take the credentials from the developer, and then we will manage them. And once we have them, we can perform all of the authentication on behalf of the developer, so they never have to see their credentials again. Now, apart from the credential management, there are three sort of categories of features that APC provides. The first is resource discovery. So this set of APIs lets you figure out what's happening inside of the network. So, for example, if you have an IP address, you can see which servers are also on the same network as that IP address, and then get the network conditions between that IP address and the servers. Now, once you have established what the conditions are, you might want to ask the network to do something on your behalf. So Ricardo mentioned quality of service, and that falls under resource configuration. So if I want to say to the network, please make the connectivity between my client and server prioritized, you would do that through a resource configuration API. And then finally, you might want to be notified when things are happening in the network that you care about. So for example, you might want to know when the network conditions between your client and server start to degrade. And so you can ask the network to tell you or notify you when these kinds of things start to happen. So that's just a quick overview of the 4 key features of APC. We have a number of adapters you can see along the bottom that let us talk to the individual APIs, but the developer should never have to worry about those adapters. They write all of their programs to this unified abstraction. And so regardless of where this code is deployed or where the clients are, where the servers are, the code should never have to change. We make sure that all of the translation happens inside of APC. Okay. So to show off what APC is really capable of, I'm going to walk you through a simple and representative video analytics workload. And then I'll show a demo of this workload in action. So what we have here is we have a number of cameras on the left that are distributed over a large geographic region. And because it's a large geographic region, these cameras are going to be on different networks. So at the top, we see that we have some cameras on a Contoso network, and at the bottom, we have them on another 5G operators networks. And so any application that is deployed across, say, a country or across continents is going to face these sorts of challenges where you have devices on lots of different networks. Now, the consumers of these video feeds are also going to be geographically distributed. And so one of the first problems that we want to solve is how do we make sure that the camera feed from one of these cameras goes to the closest cluster that can consume that video content. Okay. The second challenge that we're going to face is that once that camera feed is ingested from one of the clusters, how do we make sure that the connectivity is good between that camera and the cluster? And so we address both of these through a very simple architecture on the right here. So we have a global coordinator. It's a very simple little Python app that is linked with the APC Python SDK. And so what it's going to do, it's going to respond to requests coming from the camera, and then it's going to use APC to discover what's happening on the camera's network, and then also configure the connectivity between the camera and the cluster. Okay, so there are really 5 steps in this application. I'll walk you through the 5 steps. The first step is a camera comes online and it needs to be assigned to a cluster. So it's going to register itself with this global coordinator. The global coordinator is going to use APC to, number 1, figure out what network that camera is on. And then number 2, figure out which of the different clusters that it could send its video to is closest. Okay. Now, once it gets that information, it's going to make an assignment. So it'll assign the camera to one of these 3 clusters. That's step 2. And it's going to do so by writing that assignment into a global database. Now, each of the clusters is watching this global database, and it's looking for new assignments from the coordinator. So step 3 is the public Mech at the very top there realizes that it has a new assignment, and it reads from the database all of the information it needs to connect to this camera. So this is an RTSP feed, so it gets the RTSP URI, plus if there's a username and password, it pulls that out of the database. And then once the cluster pulls that out of the database, it can connect to the RTSP camera and start to analyze the video feed. Now, the final step is the second time that we're going to use APC, and that's step 5. So once the camera gets a connection from this cluster, it's going to contact the global coordinator again, and it's going to ask the coordinator to configure the connectivity between itself and the cluster. It's going to ask it to set the quality of service between the camera and the Mech. So that's the final step, step 5. Okay. Now, we have a simple demo to show that uses all of these different pieces, and then I can show you what the code looks like and how this thing works and what it really looks like. Okay, so I'm going to get out of the presentation now. And what I can show you here is all of the different resources in this window for the demo. So in this case, we have 4 virtual cameras. We have 2 clusters. We have our coordinator. This is the, in the middle window here, we have the console output for the coordinator. So that'll help us figure out what's happening. And one of the things that I want to mention is that these cameras aren't connected to a real operator network. They're connected through Azure. And so we're not using a real adapter. We're using a Microsoft adapter to implement all of the network APIs. Now over here on the right, I have the code for the coordinator. Okay, and I'll walk through this code, and we can look at the console output as the demo proceeds. Okay, so the first thing that I'm going to do is I'm going to go to one of my cameras, and I'm going to turn the camera on. Okay. So if you remember, when the camera comes online, the first thing that it does is it contacts the coordinator. So what we're going to be watching for here over in the coordinator is as the camera comes online, we should see the coordinator start to make some APC calls. So here's our coordinator, and we can start to go through the code as it comes online. So there are really two things that the coordinator does. The first thing that it does is it accepts registrations from the cameras as they come online. And then when the cluster starts to talk to the camera then asks to configure quality of service between itself and the server. So if we go back over to our Azure resources, we can peek inside of the database, and we can see that we have two tables, one for each cluster, and it looks like we have some console output. And so what you'll see here is we did some edge discovery, and from our edge discovery call, we got a list of edges that are located in this mock Microsoft network, including the two of the places where we've set up our video analytics application. And then for each of these locations, we can get some network information. We can get the latency between this camera and each of these locations. So we made an assignment to West US. And if we peek back into our table, we'll see that we have a new assignment for West US with this RTSP speed. So we get the IP and port plus the URI. Okay. Now, in here, we can look at what that code looks like, right? So when we're making a camera assignment, this is the call that makes the camera assignment. The first thing that we do is we try to get the closest edge. So here's some more Python code. The things that I want to point out here are the two APC calls. So the first is we try to get the edges for the particular network. And you'll notice how simple this code is. We're just calling get edges. There's nothing in this code that knows anything about the particular network that the camera's on. Okay, it's all network agnostic. So we can deploy this code anywhere in a supported network and it will work. Okay, no changes. Now, once we have the list of edges, then we're going to go try to find the one that's closest. So we're going to iterate through these edges, and for each one, we're going to make a get properties call. Now, this get properties call lets us understand the network conditions between the client, which is the camera in this case, and each of these edges that we might want to send it. So we go through and we make that call for each one. That's the output here in the console. And then we make an assignment. And then once we have the assignment, then we insert it into the database, which we saw here. Okay. Now, the second part of this, apart from the assignment, is once there's a connection, then we set the quality of service. And so you can see that in the output here, where we are setting the QoS between our client and our server. So that happens in the set QoS call. And so it's a very similar set of APC calls. Then what I want to call your attention to is set properties. So before we were asking the network about the network conditions between the client and server using get properties. Here, we're trying to configure the connectivity between the client and server using a set properties call. In this case, we're just trying to set the latency to a certain amount, and then the network will go off and do what it can with that request. Okay. Now, going back to our application, we can see the effect of all of this is that we've dynamically assigned a camera to one of these clusters. In this case, we assigned it to West US. And so we can look at the workloads that happen. We will see that we've dynamically created pods right here that is consuming all of the video from that camera right here. And so as it consumes and monitors the video, it's going to create events. It's going to look for people. And so if we head over to our event dashboard, what you see is different people that have been identified in the camera feed. So all of this happened dynamically. And if this camera had been on another supported network, nothing would have changed. The camera would have been assigned to a different cluster, but the cluster would have processed the video in exactly the same way. And so that's really the power of APC, is that we can do all of this in a network agnostic way. And so let me go back to the slides. So if you want to learn more about APC, here are some links that you can follow. So Ricardo and I wrote a blog after MWC announcing APC. And I don't know, Ricardo, would you like to go through these? Describe each of these links?
Yeah, just very quickly. Yes, APC blog. So you don't have to take notes of everything we said. Everything is there. You can see exactly what is it that we are trying to solve, the vision, the product. You can also go to the following link, which, by the way, is also in the APC blog. So the only one that you have to remember for that is the one on the top. But the second link that we are showing is to apply as a developer to use this product in private preview version. So we obviously, because it's private preview, we need to talk to each developer that would like to use it, and then we need to understand how they would use it, and then based on that, they can be approved to use the product in this version. And then lastly, as I said, this is one of the results that why we are doing this is because applications are evolving, and we've been calling this it's a paradigm that we are calling modern connected apps. There's a newsletter that you can subscribe to, and that's the last link, basically.
Yeah.
With that, we are open to questions. I think there were some questions here that were happening. Yes, they were asking if Mech stands for multi-access edge computing. Yes. So we were showing that many applications are running on a public Mech or on a private Mech. A private Mech is on the premises of the developer, and a public Mech is a multi-access edge computing location that is co-located within the telco operator premises. So it's right there in the network, next to the network, but it's public in that sense. Someone else was asked. So go ahead.
Actually, there was one other thing I wanted to add to that, which is the application that we demoed. This is a Microsoft Mech solution accelerator that we integrated APC with, and so it's specifically designed to run on a Mech, the application that you saw. And so part of what we've been doing is taking other software like this Mech solution accelerator and sort of injecting APC into it to make it more powerful. So one of the things that we were able to do is take this existing solution and make it more dynamic. So when the cameras come online, they can automatically be assigned, and all the right pods spin up to start analyzing the video. And it all happens dynamically with the help of APC. And so that was one way in which we've been able to take this one Mech application and make it more network aware. Sorry, go ahead, Ricardo.
Yep, excellent. Going down the list of questions, I see that T-Mobile is listed twice. No, the thing is that The logo for T-Mobile and Deutsche Telekom are so similar. The one with only the T is Deutsche Telekom. The one that has the T and says mobile, it's T-Mobile. So we have 6 operators. In North America, we have AT&T, T-Mobile, and Rogers in Canada. And in Europe, we have Telefonica and Deutsche Telekom integrated, and then in Asia, Singtel. But we are talking to many more operators. It's just that it takes sometimes for even the agreement. So they are not public. As soon as they are public, you will see it in the links that I mentioned before. Those are the questions that I found. I think no more questions. Alexia, do you think we should give more time? Should we finalize the session? What is your recommendation?
Yeah. Oh, I just saw that there is one more question that came up, but we can leave another 2-3 minutes for folks to ask their question in chat. Enough. If not, you can wrap up.
Yep, that works. So let me see this question. The question is, do you see the APC service being called directly from edge devices like a mobile phone? Or will it be like your video camera example and there's a server-side application that it calls on?
So I think that's a great question. I think our model is that it is a server-side invocation. And that's just, I don't think that's necessarily a hard and fast rule, but that's generally how we think of it. We think of it as something that is called by an application that's running inside of Azure.
So next question, how long does Microsoft expect this to be in preview? So the program that we have right now, if a developer is accepted into the program, if they have a use case that they can use these APIs, from the moment they are given access to this product, they have 3 months to test. And the idea is that it's at no cost for the developer. We would be providing Azure credits, and the operators would not be charging for the API calls. And then there is a possibility for extension to 6 months, depending on how it is progressing. So it would be between 3 and 6 months. Yeah, will there be a charge for calling APC services? Not in the private preview, right? Not right now. Operators are not charging. We are not charging. We are even providing Azure credits. We want to promote the development of applications in Azure. Eventually, yes, it's an idea. We don't know yet how operators are going to charge exactly. Those are conversations we are having with them on a weekly basis. But the idea, obviously, is that these are services that operators want to monetize, right? They would be premium services that applications can use. Another question, if an application that uses APC fails, does that cause an outage at the edge device?
No, I don't think, it would largely depend on the way that the application itself is developed. But if APC for some reason fails, then all of the network API calls would still be executing inside of the operator. And I don't think it would cause an outage at the edge device. It's an orthogonal issue. Yeah.
Another question, are the APC applications stateless? Meaning, can they be upgraded? Oh, go ahead.
Again, it depends on how they're written. So for the one that we demoed, the Python code is stateless. The state is stored in the global database, so there is state in that sense. But certainly you can bring up the global coordinator, bring down the global coordinator, replicate the global coordinator, and everything would execute the same way. All of this data is in the database for this demo. Yeah. That is a great question, and something I wish that I had. So the question is, what languages does APC support? So we have currently for private preview, we have an SDK for C#, we have an SDK for Go, and we have an SDK for Python. It's very easy for us to create these SDKs. So depending on the languages that developers are interested in, we can create them for JavaScript or Rust or whatever developer wants. Will there be test networks or network simulators to test APC applications? So we have a test network in place now. That's the Microsoft Mech network that I used in the demo. And that's really in place so that you can build your application, run it in Azure, get a sense of what the programming experience is like. So yes, we have a test network already. It's simply the Microsoft network, and we have support for it. And that's what you saw in the demo. So our Mech, the question is about a Mech. So our Mech is just an AKS cluster running in Azure. So, we had a Mech Atlanta Mech in the demo, but it was really just an AKS cluster running in West US 3. And I should mention for our Mech Microsoft Network APIs, we were generating just random latencies. They don't correspond to anything in reality. Again, it was just for testing purposes. Thank you for your questions.
I think that is it. Nope, one more. Can the APC application run on-prem or only on Azure?
Yeah, so in production, we would like it to run on-prem. For the private preview, it has to run in Azure. So these are the kinds of things that Ricardo and I will be working through as we define the final product. But for now, it is our intention that applications be allowed to run on-prem, and we think that's reasonable.
Yep. Alexia, I think we are ready to wrap up.
Fantastic.
Did I wrap up or do you wrap up?
Well, you can, if you have one last words to go towards the session, feel free. If not, I will take a few seconds just to share our survey link. I dropped it in the chat. Feel free to share your feedback on the session, on what you would like to learn in the future. The event code is 19038. And yeah, thank you both, Lyndon and Ricardo, so much for joining us today. It's been great. Lots of questions, lots of interactions. So really awesome. Thank you. And if you have one more thing to say, feel free.
No, just to thank everyone on my side. Thank you, everyone.
Yeah, same. Thank you, Alexia. Thank you to everyone engaged.
Awesome. Thank you. Have a great day, everyone.